He's not coming in, is he?
Edit that bit out. Right. The expression 11 plus 8x over 2 minus x, 1 plus... this question, do you notice this? I think this was a bigger question that I edited. I did it last year. But I think I cut out part 1, which said show that. That can be written like that. And it goes straight into, given that the modulus of x is less than 1, find the first 3 terms in the expansion. So we've got to expand.
I didn't expand it, I just showed that.
Okay. So we're going to expand this stuff here, which is 3 lots of 2 minus x to the minus 1, plus 3 lots of 1 plus x to the minus 1, plus 1 plus x to the minus 2. And we've only got to do the first 3 terms in ascending powers of x. Ascending means start small and get larger the numbers. They go up each time. Unlike how you did in the D1 trial exam, where ascending apparently meant descending. No? Okay, so we're going to work out these individual ones here. 2 minus x, let's start with that. Remember that has to be 2 lots of 1 minus x over 2, all to the minus 1. Because we need to get it as a 1 plus thing first, which is 2 to the minus 1 times 1 minus x over 2. We're ready to do something now, which is a half of, and remember the expansion, it's 1 plus n times x, so minus 1 times minus x over 2, plus n times n minus 1 over 2, times the x bit squared. And we're only wanting to do the first 3 terms. So that's as far as we're going to go with this. It would go on, but we don't need to, which is nice. So this is a half of 1 plus x over 2 plus x squared over 4. Once that's cancelled down, and so on. And let's multiply through by the half, and then we'll deal with the rest of it later. That's a half plus x over 4 plus x squared over 8, and so on. Right, so that's 2 minus x to the minus 1 expanded, and on it goes. We're now going to deal with 1 plus x to the minus 1. Well, that's already in the form that we want it, so that's going to be much easier to deal with. That's 1 plus n times x plus n times n minus 1 over 2 times x squared, and so on, which is just 1 minus x plus x squared, blah blah blah. And the final one, we'll deal with those other numbers in a moment, David.
Is it fine if you do that?
It's fine if you did that straight away, yeah. So we've got 1 plus x to the minus 2, which is 1 plus n times x plus n times n minus 1 over 2 times x squared, and so on, which is 1 minus 2x plus 3x squared. And then we carry on. Well, this is going well. Now we need to put this together, and we've got, altogether, we've got 3 lots of this one. I can't be bothered to write it out again. The answer is 3 lots of that one. And then we had 3 lots of the next one. Plus 1 lot of the last one that we did. I think, is that right? Yeah. Which gives us, if we work out the numbers first, we have 3 plus 0 is 4, take away 1.5, so that's 5 over 2 as our first term. Do we agree with 5 over 2? Oh no. Right.
Does anyone agree with
Does anybody agree with 5 over 2?
It's not 5 over 2, is it?
Is it not?
No.
Good.
You got 3 to add on.
Yeah, subtract it, yeah. That's 4 plus 1.5 is 11 over 2. Yay, good. Well done. Just checking there. And then we got 3/4 of x. Oh, what have we got? We've got minus 5x plus 3/4 of x. That's minus 4.25, which is 15. Yeah, that's it. There we go, that's looking good. And then we've got 3 plus 3 is 6 plus 3 over 8. That's, yeah, I can do this. 51 over 8. Oh dear. Wow. It doesn't feel much like a nice answer, but that's the answer. Georgie?
You got 2 of the terms right, but one of them wrong.
Yeah, how many marks have we got? 5. Well, you've got 2 of the terms right. Which term is wrong?
The middle one, because I got it. Just go up a bit.
Have 4 marks then.
Yeah, I got. I got a half minus a quarter x plus x squared over 8.
What about if you did 2 of the bottom?
Did you see those 2?
Question 2. It's asked us to expand 1 minus 3x to the minus 3rd in ascending pairs of x. Oh, ascending. Remember that?
3 marks.
Not descending. Well done.
You've got
Is that like smallest to biggest?
Yeah.
F. Now this is already in the right form, so we're going to start with 1 plus n times x plus n times n minus 1. Now, I bet some of you have got this wrong. What is it? Minus the 3rd, take away 1.
Minus
2/3.
Minus 2/3, great. Well done, James. Minus 4/3, of course. Over 2 times minus 3x squared. And we've got to go for the next term as well. So minus 1/3, minus 4/3, minus 7/3 over 6 times minus 3x cubed. Right. Can we type this up? 1 plus x. That's all right. Here we've got great stuff going on. Plus 2 x squared. Here we've got the 3 and the 3 cancel out, don't they? It's 27. That's nice. So we've got plus 28 over 6. So 14 over 3. X cubed.
Technically I got them all.
So there you go, 4 marks for that. That's pretty good.
Quick point. This isn't me this time.
Yeah.
If the person I know, if they put 3x rather than minus 3x in all the things, so therefore got alternating minuses, would they get 3 marks?
I think that'd be really nice.
3 or 2?
3.
3, okay.
Thank you.
I know what you meant to do.
Part 2.
Dave, are you
Yeah?
meant to put like the modulus of x in
Well-
between limits? Oh,
It didn't ask us to.
but you meant to do it automatically.
I think we probably ought to, just to be absolutely certain here. It would be minus 3x between minus 1 and plus 1. So that would be x between minus the 3rd and the 3rd. That would be the
Did you do the whole thing again?
I think in this case they probably wouldn't.
Format. Would you favour the word format?
There are 4 terms. It's not really worth.
The 1's worth of that.
One.
So if you just put 1, you've got
Well
marks.
done.
Is that what you did?
Hence find the coefficient of x cubed in that exponential. Right. Hence find the coefficient of x cubed. So what we're doing, basically here, we're replacing x with x plus x cubed, aren't we? So instead of x, we're going to put in x plus x cubed. So our expansion becomes 1 plus x cubed plus twice x plus x cubed squared plus 14/3 of x plus x cubed cubed. And we only care about the x cubed term. So if we think about the x cubed term in all of this, we would get an x cubed term from there, wouldn't we? That's 1. If I think about this bit here, by the time you've multiplied this out, none of it would leave us with x cubed. You'd have x squared, and you'd have x to the 4 and x to the 6. This one, you would end up with only the first x once you've cubed it out being x cubed. So we've also got a plus 14/3 from that bit there, and so the answer is 17/3. And that's it. That is all the x cubes that there would be. You don't have to do any more work than that. That's it. Yes.
Carrying on from before, if you've used the same method.
I got it wrong.
Well, if it's right from the method, then certainly 2.
I don't know if it is right from the method though.
And that's maths.